They call it a Type 6 civilization. It's the final level of a futuristic scale that measures how advanced a civilization is. It's called the Kardashev scale. But who made this scale and why? And yeah, how does our human civilization rank on it? We owe the scale to Nikolai Kardashev. He was an astrophysicist and one of the best radio astronomers of the past century. He got interested in astronomy at an early age. The future scientist worked hard and earned his PhD in 1965. Then he published an academic paper that introduced the scale with his name. Fellow astronomers got interested and expanded Kardashev's scale. At first, the scale only had 3 types of civilizations. One of the people that modified the scale was Carl Sagan, the famous American science writer. The key word to understanding the Kardashev scale is energy. Possible societies from other planets are measured by the amount of energy their technology uses. The more energy a civilization is able to harness, the more powerful the signal it can send. This means we would be able to detect them first. The principle is quite simple. Imagine you were stranded on a desert island. If you manage to light a fire, there's a high chance a plane or a ship will spot you. But imagine you had a signal flare. It would go high in the air, so it would be easier for the search party to find you. Kardashev's scale measured transmission distance in theory. Think of this radio signal as the flare I've mentioned. The most technologically advanced civilization would be able to send the signal the furthest. The more energy a proposed civilization had, the more powerful it was. The famous astronomer decided to rank civilizations in this way. A Type 1 civilization is also called a planetary civilization. A suitable name, as this civilization only has the capacity to harness energy from its home planet. This includes the energy that reaches the planet, such as sunlight. Another form of energy is one the civilization can produce itself. Think of power plants, wind farms, and hydro plants. Sounds a lot like Earth, doesn't it? Yeah, not quite. You see, we are not even a proper Type 1 civilization. Carl Sagan ranked Earth as 0.72, not a full 1. In comes Michio Kaku to explain. This theoretical physicist is one of the best-known popularizers of science today. In his mind, a Type 1 civilization should be able to control the elements, such as volcanic eruptions and the weather. This also includes those nasty shakings of the Earth. Humanity can't even predict these, let alone control them. Ocean cities are another example of technological achievement. For now, underwater cities are something that we can only see in movies. That's why Michio Kaku believes that Earth won't reach Type 1 civilization for at least a century or two. This stage in the development of civilization includes the complete use of resources on the planet. From the energy of the sun to the minerals hidden underground. Then this society would be kinda ready to upgrade. A Type 2 civilization would expand its search for energy beyond the home planet. That's why this type is called an interplanetary civilization. In terms of scale, this would mean using 10 billion times more energy than a Type 1 society. Sagan made this calculation. It would involve more than collecting the sun's energy using solar panels. Yes, I'm talking about going directly to the source. In theory, the best way to achieve this is to use a Dyson sphere. This is an engineering project on a massive scale. The idea is to encircle a star, like our sun, with orbiting platforms that would form a sphere. The goal is to harness the star's energy and use the platforms as living space. Sounds out of this world, right? Well, that's because it is. The megastructure got its name from the American theoretical physicist Freeman Dyson, who first proposed it back in the 60s. He believed that the sphere would be the way possible extraterrestrial civilization would generate energy. If we spot one in outer space, there is definitely an advanced society behind it. For humans, the Dyson sphere might become a reality in 1 or 2,000 years. That's how far we are from becoming a fully fledged Type 2 civilization. That's a long time. I mean, 1,000 years ago, we were in the Viking Age, nowhere near the world we live in today. But wait till you hear how long it would take us to reach Type 3, a full 100,000 years. This civilization would go beyond its home and other planets. It would master entire galaxies. This far into the future, who knows if humanity would still exist? At least in the format we know of it today. Robots would probably be constructing Dyson spheres across faraway galaxies. Are you tired of getting stuck in traffic jams on your way to work every day? The laws of physics state that the fastest you can get there is at the speed of light. To us, this speed is astounding. But for future civilizations, this would be slow. They would need to warp space and time to go faster. Yes, exactly like the warp drive from Star Trek. Or they could develop wormhole teleportation. We are barely a Type 1 civilization, so we can only guess what a new technology a Type 3 will use to travel across the universe. This advanced society would probably be able to extract energy from black holes. Another possibility is that they could manipulate molecules. They would create new materials out of nothing. If such a powerful society exists, humanity should not hope to come in contact with them. So far, we are technologically inferior. Kardashev thought of Type 3 as the most advanced civilization possible. He didn't feel the need to further develop his theory. But other science enthusiasts didn't stop there. They expanded the scale with extra types. In the new scale, a Type 4 would harness the energy of the entire universe. They wouldn't need to live on a planet, but would inhabit black holes. The energy sources they would use are unimaginable to us. These societies would be so advanced that they would use laws of physics humans haven't discovered yet. So, is there anything left for a Type 5 civilization after Type 4 mastered the whole universe? Yep. Because who said there had to be just one universe? Their society would source power from multiple universes, that is, multiverses. At Type 6, a civilization wouldn't have to worry about energy. It would be so advanced that it could create universes. These beings would probably be able to control space and time. They would have the status of a deity. At some point, this civilization would probably become one entity, a supreme single mind that would control all existence. It would be the only one to understand what a more advanced type of civilization would look like. We Earthlings don't stand a chance of grasping the concept. But it's not all bad news for the inhabitants of the blue planet. We have the possibility to move up the scale. Kardashev made the scale to measure civilizations beyond Earth. He gave our planet only as a starting point. We are advancing slowly, but every new power plant humans build is a step closer to a proper Type 1. Scientists estimate that every time we increase our total energy supply by a quarter, we advance 0.01% on the scale. This occurs every 5 years or so. Not a huge push forward, but we're getting there. The key to reaching Type 1 and beyond is renewable energy. Every now and then, scientists discover a new source of energy. Geothermal energy and offshore wind power are just a couple of examples. Each time we find a new way to power our world, we get a step closer to a planetary civilization. So far, the energy of the sun seems the most promising. There are already solar panels at the International Space Station. So how alone are we in our galaxy? Crickets. Yep, we're mostly alone out here. But are there other civilizations lurking somewhere out there in the depths of the Milky Way? Could they possibly have evil intentions and be a threat to us? Hey, like we need more threats. Well, hey, let's have some fun with this. Some theorists reviewed humans' history and past actions toward one another. No miscongeniality awards there. And assuming they were somehow like us, used this to calculate the probability of space invaders. They determined that there could be 4 evil civilizations in our galaxy. The 4 could be eager for intergalactic domination, or maybe just for a good game of dominoes. They could be highly advanced in technology, or they've only just invented an evil version of game consoles. To understand how advanced these cultures could be and what to expect, there is a way to define their threat levels. A method called the Kardashev scale analyzes intergalactic nations' possible abilities. With 3 different levels, it reviews the amount of energy a civilization could take from their star, indicating their tech level. This only includes those that have reached interstellar communication. So any other beings out there using, let's say, space pigeons will of course be excluded. Type 1 shows that they can harness the energy from the sun, but only from what is received within their own planet, like solar power panels. Type 2 is where they can use the energy directly from the sun, like through a Dyson sphere. It's used to harness all of the sun's energy, having been built entirely around it. And lastly, Type 3, where civilization can use all elements provided by the galaxy, with the power to not only harness the energy from stars, but also black holes, even the central supermassive one. These levels are important to assess how advanced civilizations could be out there. The Milky Way is estimated to be around 13.6 billion years old. Modern humans have only been around for the last 200,000 years, and we're only a Type 1. It's scary to imagine the time other beings have had to develop. We're considered a bit of a late bloomer in comparison. Earth is, shall we say, late to the party because we're located on the outer arms of the galaxy. Mathematicians posit that more centralized star systems have had more time to progress. Now, with that in mind, how common would other intelligent beings be in the galaxy? With all the life-ending events Earth has survived, it's a miracle to have a planet like ours, and that we would be unique. Or are we? Well, there are 100 trillion stars in our galaxy, and there are up to 200 billion planets, with an estimated 300,000 exoplanets capable of sustaining the kind of life we know about. From those habitable planets, how could we tell which ones have other beings eager to send us an email? No one's had the time to individually count, of course. The Drake equation can give us some rough numbers if we take averages of a few key factors. It breaks down the criteria of how many planets with life are intelligent enough to make communication. The numbers are huge, considering how many stars might have planets. And from there, we distill it down further to those within the habitable zone in the solar system. This zone is called the Goldilocks zone, as it's not too far from the sun and not too close to it. It's just right. We reduce the numbers even further by calculating which of those habitable planets will then be able to support life. And from those random places, the equation takes the probability of how many intelligent beings will be and if they are intelligent enough to communicate. The criteria is complicated, and so it's not an easy equation to explain. But from its estimate, there could be up to 100 million planets with intelligent civilizations. But just like with Earth history or struggles, these civilizations may also have their own challenges. World-ending events should be thrown into the equation, like asteroids, solar flares, supervolcanoes, and supernova. They could also destroy themselves through technology, like AI dominance or nanotech, or by affecting their own ecosystems and running out of resources, or by just acting stupidly. If we take these into the equation, the remaining living civilizations could be around 15,000. But what could they possibly want from humans? We do have an abundance of rare earth materials that could be of value, ready to be harvested and easily collected. Besides an appealing vast amount of water they could suck dry, hydrogen is a required element of rocket fuels. Though these things aren't exactly rare in the galaxy and could be harvested easier from other closer solar systems or asteroids. Our technology might be intriguing to them. Our range of innovations on Earth, invented while being isolated in separate countries, help provide different technology paths around the world. Other civilizations could have followed a completely different route, and didn't learn the importance of many things we have here on Earth, like karaoke. The same goes for applied sciences, where they may have evolved in different atmospheres with different elements. Their science would be mainly affected by that, and ours would provide them with more knowledge. Then, there's one of the rarest things in the galaxy, that Earth can support life. This would be very useful for an intergalactic traveler, rather than going through the long process of terraforming an unlivable planet. Why not just take it? With a cozy outpost, it would be a lovely little holiday destination when they need some time off from conquering other civilizations. Fortunately, they wouldn't be interested in eating us, or probably wouldn't have an appetite for anything on Earth. They would need to have similar biochemistry and require the same enzymes to process the molecules we're built from. Whew. But the most likely thing they would want is to remove any competition. The biggest threat to them is anything that would provide a challenge to their domination. But before you get too frightened by these evil civilizations, this was based on human behavior. It's possible that any beings out there could lack or avoid many of our human emotions. For instance, their capacity for anger might be limited, or they could have evolved without it. They could come from a world with a history so different from ours that they could be overly trusting, making us the bad guys. But again, they may also lack empathy and other positive traits we have. Well, let's hope they only have our nice traits. Luckily, there's a big thing that separates us from everything else. The galaxy is huge, and it takes a very long time to go anywhere, even to our closest solar systems. The fastest thing we've sent into space is the Galileo probe, which travels up to 100,000 miles per hour. Even so, it would take 72,000 years to reach the closest star system, Alpha Centauri. Still, with a newly proposed laser-guided probe that could travel at 1/5 the speed of light, it would yet take up to 20 years to make that journey. On a larger scale, the Milky Way is over 105,700 light-years across. If a civilization was even capable of light speed, it would take them hundreds of thousands of years to travel from one end to the other. With a huge distance between the small number of civilizations, the only successful contact would be through advanced interstellar travel. But to achieve such a long journey, the greater the mass to be accelerated, the more energy is required, so it's not likely anything too large will be sent. But they could travel here very quickly in a small shuttle, using the ability to break cosmic speed laws. They may already be here, watching us closely, or just binge-watching Netflix. They would need very advanced technology, and the number of species obtaining this is theorized to be only 2 out of the 15,000. That means there's a 1/100% chance of evil civilizations capable of visiting us soon. If they do know we're here, and they want something from us, it's likely to take them thousands, if not millions of years to arrive. So, we've got plenty of time to relax.
Did you know that humans are real space people? You were born in space. Heck, even I was born in space. We were all born in space. But for humans to be here on Earth, so many conditions have to be precisely correct that it's highly improbable that we even exist. But we do. First, we, and any other space creatures who might be out there, have to live on a planet orbiting a yellowish-white star, not a red star or a blue star. Not a blue star, because they burn out too quickly. In a few million years, there wouldn't be time for evolution to do its relatively slow magic and produce intelligent beings. Blue stars also tend to swell up and turn red when they collapse and explode. It makes it highly unlikely that any civilization could prosper near a blue star. Red stars, which are by far the most numerous kind of stars, don't seem like good prospects for intelligent civilizations to orbit around either. Red stars are so cold and so dim that a planet that could grow a civilization must orbit very closely to the red star, which would expose the planet to intense deadly X-ray radiation. So, though red stars are the most numerous and appear to have many planets orbiting them, red stars are a no-go for hosting intelligent, civilized life like our own. That leaves the yellowish stars, about 10% of all stars. However, an important fact must be met before considering the possibility of intelligent life living around a yellowish star. That fact is that the yellow star must be a third-generation star. Only third-generation stars will contain sufficient chemical diversity to sustain advanced life forms. Each time a star explodes, heavier, more complicated elements are created. The explosion expelled these elements and eventually found their way into a nebula. Gravity within the nebula will gradually form the next generation of stars, and so on. Our bodies need calcium for our skeletons and teeth. Our brains need zinc to help create the electrochemical signals that make us move, feel, and think. Our blood needs iron. Therefore, our bodies need to have formed around a third-generation star, and a yellow one. Amazingly, Earth has all the different elements in the universe, all 94 naturally occurring ones, from hydrogen to plutonium. Maybe that's why we're here. And we have to thank our third-generation yellow dwarf sun for that. Why yellow? Because yellow stars burn very steadily by nuclear fusion, without significantly changing brightness over billions of years. If our sun became just 6% brighter or dimmer, Earth would become too hot or too cold to sustain civilized life. Fortunately, Earth is in the habitable zone around the sun. The habitable zone is where liquid water can exist on a planet. But that brings us to the second condition necessary for intelligent life to live in space: the planet itself. Recent studies with the Kepler telescope have shown that 1/4 of all yellow dwarf stars may contain Earth-like planets in the habitable zone around yellow dwarf stars. That figure is somewhat debatable. It might be as few as 1 out of every 33 yellow dwarf stars, but that's still a lot of planets orbiting yellow stars in habitable zones. So let's consider the second essential component for intelligent life in space: the planet itself. The planet that would bear intelligent civilization must have many particular characteristics that aren't easy to come by individually, and even more rare to find in combination. Most importantly, the planet must have protection against the star it's orbiting. Because stars shine by nuclear fusion in their cores, gas in the outer shell of the sun, called the corona, gets blown off into space in what's called the solar wind. Our United States satellites take constant readings of the force of the solar wind, which is mainly electrified, ionized, hydrogen nuclei, along with a smattering of atomic nuclei from the many other elements found in the sun. It's not the atmosphere that protects Earth, it's the magnetosphere that stops or deflects the dangerous solar wind, causing aurorae when the solar wind is attracted to Earth's magnetic poles and electrifies the air of the upper atmosphere like a fluorescent bulb. Without a magnetosphere surrounding it, any planet, even those in habitable zones, would be toasted by a constant rain of ionized hydrogen nuclei from its star. A planet with life on it must have a magnetosphere strong enough to deflect the solar wind. Not every planet in our solar system has a magnetosphere. The gas giant planets, Jupiter, Saturn, Uranus, and Neptune, have magnetospheres, but gas planets cannot have civilizations. Of the solid worlds, only Earth and Mercury have magnetospheres, and Mercury is too weak to stop the solar wind because of its closeness to the sun. Another protective shield that keeps the Earth safe from the sun is its atmosphere. The atmosphere is about 300 miles thick, with most of it concentrated within just 10 miles of the Earth's surface. The atmosphere protects life on Earth from both the sun's ultraviolet, UV, radiation, and X-rays. The gas, ozone, which is 3 oxygen atoms bound into a large gas molecule in the upper atmosphere, blocks most of the sun's UV radiation from reaching the ground. The planet Mars, whose atmosphere is 1,000 times thinner than the Earth's, has no ozone, and the sun's ultraviolet emissions have totally irradiated its surface. A planet must be able to stop the UV radiation from its star, so the specific composition of the atmosphere is critical for any planet to have an intelligent civilization. We've got it, but it is a rare and precarious mix. The planet must have some part of its surface solid to walk and work on. The planet must have a crust. It's pure science fiction to consider underwater civilizations or floating civilizations in the atmospheres of other planets. A planet's crust must have tectonic plates that move. This movement of tectonic plates creates the subduction of the crust. Subduction is when one tectonic plate slides under or over another, bringing the fresh matter to the surface. This renewal of the chemical properties of the planet prevents chemical equilibrium, where nothing is reactive. Earthquakes and volcanoes also contribute to the process of geochemical renewal. That's right, earthquakes and volcanoes are good. Subduction of tectonic plates, then, is another planetary essential for life. Mars doesn't have tectonic plate activity, neither does Venus nor Mercury. Mercury is one big tectonic plate, but there's no ongoing plate activity other than slight shrinkage. One big reason these planets have no life is that there's no geochemical reactivity because there's no tectonic subduction. And that brings us to the moon. Yes, the moon. To say that the moon keeps us alive may seem like a stretch. But the contribution of the moon to life on Earth is essential. First, the gravity of the moon as it moves through space with the Earth not only makes the ocean tides ebb and flow, it also helps the rotation of the Earth to churn or stir the magma inside the Earth. The motion of the magma inside the Earth, with its high metallic content, contributes to the creation of the Earth's magnetosphere. So, the moon keeps us safe in space by helping Earth become a geodynamo and creating our magnetism. The moon is the largest moon in the solar system compared to the size of the planet it orbits. Essentially, it's primary. Many people consider the Earth-Moon system to be a double planet, but that's another issue. Another thing the moon does that keeps life safe on Earth is to hold the Earth steady. Because the moon is gravitationally locked to the Earth, the moon acts much like a balance pole does for a tightrope walker. Therefore, the Earth doesn't wobble very much compared to other planets. This wobble is called libration. If the Earth wobbled as much as Mars or Saturn, not only would our weather become chaotic, but farming might have been impossible. These rare or unique astronomical circumstances work together to make Earth habitable for humanity. Many other factors are not astronomical, such as evolutionary, biological, and chemical factors required for life to exist on Earth. The probabilities, or improbabilities, are multiplying. Taken all together, we are very, very lucky to be here. In fact, we're so lucky that we may have hit the jackpot. Considering all the possibilities, it's doubtful that anywhere else in the universe is as fortunate as Earth.